Hi everyone, I'd like to just give you an update of my testing here with resonance, and I've reached a higher level of resonating a coil, and I've actually have a new coil here which is taken from a shaded pole motor. For those of you who don't know what a shaded pole motor is, this is a shaded pole motor. And you've probably seen these in fans for like bathrooms. This particular shaded pole motor was taken from a microwave oven, and I had many of those since I picked all the microwave ovens that I can find in the garbage. And you usually find these as the fan that's circulating air through the microwave oven. And basically all you do is you cut it open on the side here with a nice cut-off blade on a grinder, and you can take out the core, which is a metal core, out, and it just slides right out. So the core material that I've inserted in that is a ferrite rod that I actually even broke off a piece. And the ferrite is not filling the gap completely, so there's an air gap all around. And with that combination, I'm getting the best result. Filling it necessarily doesn't give you a better result. And so there's the coil. So basically my signal generator is coming in to the coil, and the other side of the coil here I've got this small capacitor in series with the return to the signal generator, and that some small capacitor is 0.0056 around that area microfarads, so about 0.56 nanofarads. And the frequency on the signal generator is still on square pulse, and the frequency is about 1760 hertz. Sorry, 17,060. All right, so that's the frequency it resonates, and resonating frequency is very, very precise. You nearly need an oscilloscope to find it. It's very difficult to just play around with it and do it without the scope. So there's the capacitor, which is again the same 2 microfarad capacitor, and that capacitor can hold up to 2,500 volts DC. And right now the circuit is capable of charging the capacitor at 703 volts, and the milliamp draw, that's on the milliamp scale right now, and the milliamp draw is 18.2, so basically 18 milliamps to charge the cap at 703. And the other thing that I've also found is my voltage meter is actually draining the capacitor. So if I actually disconnect one of the terminals off and I let the capacitor charge itself more, and you'll notice the amp draws are going up. When the amp draws stabilize, then the capacitor is really charged to its full potential using this circuit at that frequency and all that. So it's pretty stable right there. So if I just reconnect that voltage meter, you'll see the reading is much higher. It's closer to 1,000 volts right now. See? Well, I touched it earlier, so it dropped it, but as soon as that charges back there, and it'll be about 21 milliamps, you'll see that as soon as I connect it once, there you go, 914, and it just drops, right? So this voltage meter is really dropping the or draining that capacitor slowly, so you're really not seeing its full potential. So truly, with the voltage meter attached, it charges up to 700 volts, but without it, it's only it's capable of going higher. So I just thought I'd give you this update and show you that, you know, things can get better, and this is probably about twice as good as the other result that I had. I'm not claiming any over Unity or anything like that. This is just for sharing, and it's just for anyone who's interested in this kind of thing. And again, it's the dual diodes setup as the previous setup right here. So basically I'm taking the voltage off of one side of the coil, and it's creating the DC by splitting it. And again, I have the ground from the ground attached to it. So there's the 700 volt charge there, and if I disconnect the ground, you'll see the amperage shoots up and the voltage drops down. So definitely this circuit gets a lot of its potential power from the ground. So there you see the where it stabilizes itself, so probably around that area there. About 515, 510 volts would probably be where it could charge that capacitor. There you go. So it's stable there, and if I connect that once more, and it doesn't matter if I connect it on the negative or the positive side of after the diode, it gives the same result. And there you go, it's charging back the capacitor to its full potential. Alright, so I'll post this and keep watching, and hopefully we'll have better results. Thanks for watching. Bye.